All right, IM3 classes. Today we are going to review properties of exponents and talk about rational exponents. If you remember from earlier the rational expressions, what rational means, irrational number is a number that can be expressed as a fraction. So what we're going to be doing is dealing with exponents that are fractions. Before we get there, like I said, we need to review properties of exponents. So properties of exponents, these are the basic ones we will be dealing with. There is the product of powers, so the product property. When you are multiplying with exponents, to simplify, you just add the exponents together. If you're taking the power of a power, so the power of a power, you multiply the exponents together. If you are taking the power of a product, so this gets, so if there you have parentheses, this m, the exponent gets applied to both bases in the parentheses. Negative exponents, we'll spend some time with negative exponents. Those just flip fractions. So a to the negative m, you make it a fraction, you flip it, and the exponent becomes positive. Quotient property, when you're dividing with exponents, you subtract the exponents, and then the power of a quotient, again, just like with up here, this exponent gets applied to each base in there. Talking about these, we're going to do a bunch of examples here. The product property, simplify. So remember, if it doesn't have an exponent, there's a 1 there. So what you want to do is the variables that have the same base, you add those exponents. So m squared times m to the first, that's m to the third, and there's a 4 on top. So this just applies to 4 m to the third. 2 plus 1 is 3. All right. This is, there's a lot more going on here. So let me highlight the different ones. We have x to the 4th, x squared. And then there's a y cubed, y cubed. First thing, if you have numbers in there, so 3 times 2 is 6. Go ahead and multiply those out. X to the 4th and x to the 6th, or x squared. So that's 4 plus 2 is 6. It's be x to the 6. Y cubed, y cubed. So 3 plus 3 is 6. Again, it's y to the 6. 6, x to the 6, y to the 6. A lot of 6's in there. Power property. Like I said, this gets just applied to each base in there. And then these powers here, if there's already a power on them, those get multiplied. So this is going to be 2 to the 4th. Then 3 times 2 is 12, x to the 12th. All right. If this gets to be super big, you can just leave it like that. But 2 to the 4th, I know what that is. That's 16. So I'm actually going to go ahead and multiply that out wholly. A lot of them, you can just leave it as like 2 to the 4th. It is like 5 to the 8th. You just leave it as 5 to the 8th. But smaller numbers, we can multiply out. So here, again, this exponent gets applied to each base in here. So there's the 3 bases. There's the 2, y, and then the x cubed. So this one is 2, it's going to be 2 squared, y squared, and then 3 times 2 is 6, so x to the 6th. And then we can't multiply that out. 2 squared is 4. So 2 squared or 4, y squared, x to the 6th will be the final answer on that one. Quotient property, so simplify. So this is actually pretty much just the rational expressions we've been working in. Same thing. If these fractions reduce 4 over 3, you need to reduce them, but it doesn't, so we can just leave it as 4 over 3. And n squared, remember there's 1. 2 minus 1 is 1, so n is going to be on top. Another way to think about this, what we've been doing with the rational expressions, if I expand that n squared, so it'd be n times n, and 1 n on bottom, the n on bottom cancels out the n on top, and so then you get the 4 n over 3. All right, so here, this one, so the 4 over 3, whoa, weird. The 4/3 does not reduce. You can just subtract, so there'd be a 1 here and a 1 here. 2 minus 1 is 1, but there's more A's on bottom, so the A left over needs to be on bottom. And then 4 minus 1 is 3. Again, more B's on bottom, so the B needs to be on bottom, B cubed. I'm going to put that in the middle. And I got it. I see. Again, another way to think about this is things canceling out. So if you expand the bottom, we'll do that real quick. So it'll be 3 times A times A, and then 1, 2, 3, 4. You can see when we cancel things out, 1A on top cancels here, 1A cancels, or 1B cancels 1B there. This, so you have 4 left over on top, 3, you have 1A, you have 1, 2, 3, B cubed. So that's a good way to visualize in your head where, when you're dealing with the fractions, where the variables end up on top of them. All right, so now negative exponents. I'm going to do this in a couple steps. So first thing with the negative exponent, because there's going to be a lot to move around, I'm going to put a fraction bar. Anything with a positive exponent, since this is all one, if I do this, you can see it as a fraction. What I like to think of, anything with a negative exponent gets moved to the other side of the fraction bar. Anything with positive exponent stays where it's at. So I'm just going to move things around first. So 3 has a positive exponent, that stays on top. X to the 4th, negative exponent, moves to the bottom, becomes positive. All right. Y squared, positive exponent, moves to the top. All right. Y, positive exponent, that stays on top. X to the 4th, negative exponent, I'm going to move that to the bottom, and it becomes positive. And then I'm going to simplify things further. So these things on top multiply out. So y squared times y is y cubed. So 3y cubed, x 4 times x to the 4th is x to the 8th. There we go. All right, so same thing. I'm going to do the power property. This is going to get multiplied, go to each base in there. So it's going to be 2 squared. Negative 4 times 2 is negative 8. So k to the negative 8 times 2k. All right. Again, I'm going to put the fraction bar and just move things around the top or bottom. 2 squared is a positive exponent, so that stays on top. K to the negative 8, negative exponent, so I'm going to move that down to the bottom, make the exponent positive. Times 2, that's positive exponent, so that stays where it's at. And then k is on top. Now I can simplify. So 2 squared is 4 times 2 is 8. 1k up here is going to cancel out 1 of the k's down here. It'll be 7 k's left on the bottom. So it'll be k to the 7th. We're done. All right. So next, we need to talk about rational exponents. So rational exponents is just a different way to write a root and a power on the same in the same as an exponent instead of 2 different things. So really what we're going to be doing today is just switching back and forth from exponential form to radical form. So I like to think of fractional exponents as trees. So what do trees have on the bottom of them? They have roots, right? So with a fractional exponent, the root is on the bottom, just like a tree. Power's on the top, the root is on the bottom, like a tree, right? So notice when we write it, you put the radical symbol, the root, whatever number is on the bottom goes in the little nook of the root, and then the power is on the top. We rewrite it. So let's practice rewriting it. If it's a 1 on top, these are real simple. So root is on the bottom. So this little 2 gets put in the nook. The power is 1, so I don't really need it. And actually for the square root, you don't need the 2 in the square root because it's just the radical symbol means the square root. If it makes you feel better, you can put it in there. It's not wrong, but you don't need it. This one here, root is on the bottom, so the root is the 3rd root, and x to the 1st power. You don't really need the 1 there, but it makes you feel better, put it in there. And then this one, x to the fourth power, the root is on the bottom. The first, again, you don't need the 1 there. I'm actually going to take the 1s off. But if it makes you feel better, go ahead and put it in there. Let's do with one without a different radical here. So root is on the bottom. So you put the radical, the root goes in the little nook. So it's the 5th root of x to the 4th power. That's it. Another example, 3n. So and here's going to be 3n. I should put that in parentheses. The root, it's the 2nd root to the 7th power. Again, because it's a square root, you don't need the 2 there. It makes it feel better, leave it there. It's not wrong if it is. All right. This one here, square root. Put the 7z in parentheses. The root is on the bottom. So it's the 5th root, 4th power. The root is on the bottom, like a tree. All right. So now we're going backwards. We're going to write it as a fractional exponent. The root, remember, it's not a 1. It's like there's a 2 there. So the root, it's the square root 5th power. Root is on the bottom, power is on the top. Right here, have y. The root is on the bottom. It's the 4th root, bottom of the exponent. No exponent here, so that means it has a power of 1. All right. This one here, the root is on the bottom, so I'm going to leave the 7n in parentheses, the root. So there's nothing in the nook, so that means it's the square root, right? So it has a 2 on the bottom, 3 on top. For x, root is on the bottom, so 5th root on the, so 5 on the bottom, 3 on top. Root is on the bottom. Root is on the bottom, like a tree. All right, so now we actually need to evaluate. So sometimes these kind of interesting. You just kind of think your way through these. 4th root of 625. So if you want to rewrite it, 4th root is 625. Just help you wrap your brain around it. You can put that in a calculator. I don't actually expect you to know how to do that without it, know the 4th root off the top of your head. So on the calculator, what you want to do, there's a little button. You probably I showed it, but you probably be able to see it. Let's see. You show it. No, never mind. Forget that. 4th root. If you need help using a calculator to put in a root, I will help you in class. But 4th root of 625, that's just 5. Next example. So here, we can, it's the square root of 81 cubed. So here's the nice thing about these. It doesn't matter which one you do first. If you do the root or the power first, it doesn't matter. One might be easier than the other though. So like, 81 cubed off the top of your head? Probably not. I don't know what 81 to the 3rd power is off the top of my head, but I do know what the square root of 81 is. So I'm going to do this. I'm going to do the root first, right, and then the power. So the square root of 81 is 9, and then 9 cubed. That's a lot easier than 81 cubed. That's going to be 729. Again, use a calculator if you need to. All right. Next one. So again, 16, 4th root of 16 to the 5th power. Again, 16 to the 5th power, I have no idea. That's crazy, but I do know 16 to the 4th root is 16, so I'm going to do the root first. I don't know why I put 3. The 4th root of 16, that's just going to be 2 to the 5th power. Now 2 to the 5th, that's easy. That's going to be 32. You can do either one. Sometimes it will be easier to do the power first. Let's see if I put one on here where it's easier to do the power first. No, I did not. Not this one. 64 squared would be pretty easy to work out. So root is on the bottom. But I don't know 64 squared off the top of my head, but I know the cube root of 64 is 4. And then 4 squared is 16. So I can do that real quick. I think just one more. No, that is it. Cool. So when you're evaluating, so just remember fractional exponents, power's on the top, the root is on the bottom, just like a tree. And then if you need help evaluating them, use a calculator. I can show you how to use those calculators later on. Other than that, get the assignment done, and we'll see you next time.